So in this problem, we're looking at data that represents the annual number of days under 60 degrees in a town from the years 1905 to 2004. And they want the mean and standard deviation for the annual number of days under 60 degrees. And they're telling us, this is important, to treat the data as a population. All right, so they have a data here, and what I've done is I've just taken what they've given us and converted it into columns, just so that it mimics what I'm going to do with the calculator in just a minute. But when I look at the number of days under 60 degrees, I see classes here, or bins, and so the first one runs from 0 to 9, 10 to 19 for the second one, 20 to 29 for the third one, and so on. And then the number of years then are telling me that there are 39 or 31 years where the number of days under 60 degrees was between 0 and 9. Alright, so with the calculator doesn't deal well with ranges of data, and so this 0 to 9 is not going to be something that the calculator understands. Neither will it understand 10 to 19. So we have to give the calculator something that it will understand, and that is a single value, and what we'll use for the classes are their midpoints. And I find the midpoints by using the lower limit of one class and the lower limit of the next class, and I take their mean. And so I'm going to take 0, add to 10, that would be 10, divide by 2, and that's 5. So 5 is the midpoint actually of the first class. For the second class, the lower limit is 10. I add to that the lower limit of the next class. So 10 plus 20 is 30, divide by 2, and I have 15. And I keep going. So I have 20 and 30 are my lower limits there. So I have 20 plus 30 is 50. When I divide by 2, I'm going to have 25. And I'll do one more. I have a lower limit of 30. The next lower limit is a 40. And that's 70. Divide by 2, and you get 35. So by now you probably see a pattern. Looks like our midpoints are spread out here by 10 points. So 5 to 15 to 25 to 35. We get 45, 55, and 65. So in terms of the calculator, what I'm going to do is put the midpoints in list number 1, and then put the weights, in this case the years, in list number 2. So let's go try that with the calculator. So to put my data into the list, I press the Stat key and choose number 1, which is Edit. And I see I already have something in my list, so I'm going to toggle up and land on L1. See how it's highlighted? I'm going to touch the clear key and then the down arrow key, and it all goes away. And so list 1 is where I want to put the midpoints. So I'm ready for my 5, 15, 25, 35, 45, 55, and 65. And then I toggle to the right, and I'm in list number 2, and that's where I want to put those frequencies. So here's the 31, 30, 20, 12, 4, 2, and 1. Okay, now I'm just going to back away from the screen by quitting the screen. So I'm going to hit Second and Mode, and I'm back at my home screen. I'm going to mash the Stat key, and this time I'm going to toggle to the right to Calc. And I want choice number 1, which is called One Variable Statistics. And it puts one var stats on my screen, and the calculator is waiting for me to tell it which list to look at. And I have 2 lists that I want it to focus on. So I do second L1, right, or second number 1 key to get L1 on my screen, a comma, and then second number 2 to get the L2 there. Now if you have a more up-to-date operating system, then it might prompt you for the L1 and L2 at the menu here on your screen, but when you hit enter, it's going to show you the same kind of syntax, the one var stats L1 comma L2. Just hit enter, and here's the results. Now the thing to remember here, is that they told us to treat the data as a population. And that's mirrored here in the answers when they're prompting us to enter the mean, when they're showing us a Greek letter here, the mu, for mean instead of x bar. The calculator doesn't understand that though, right? It will never show me a mu on the screen. It'll always give me an x bar. So for the mean, use the x bar value of 18.8. However, the problem is probably next going to ask you for the standard deviation. And because we're treating this as a population, it's going to prompt you for a sigma value, the Greek letter sigma. And so when you look on your calculator screen, you want to make sure that you're using the sigma value, the 13.325 value. If this were a sample, right, if they told us to treat the data as a sample, I would use the S value, S for sample and standard deviation, which would be 13.392. Right? But because it's a population, you go for the Greek letter sigma. So use the 13.325 value. And I hope that helps.